Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on errors dealing with the two sample T, smartphone dumb kids. All right, we previously ran this hypothesis test, so if you want to see the entire hypothesis test, it's in a previous video. So here's the scenario again. A study is conducted by a group of educators investigating whether excessive smartphone use negatively impacts the student's academic performance. While smartphones can be a source of distraction during study time, they may also serve as educational tools. To analyze the relationship between smartphone use and academic performance, they ran a random sample from a large school district with over 25,000 students. Two independent groups were formed based on daily smartphone usage. The first group consisted of 63 students who used their smartphones for more than 5 hours a day. Randomly selected students from thousands of students with similar smartphone usage. The second group included 37 students who use their smartphones for less than 2 hours a day, randomly selected from 1,500 students with comparable phone habits. The findings are summarized in the table below. So we have one group with high smartphone usage, and they have a GPA of 2.5, low smartphone usage of 3.4. And then what they want us to do, test whether the high smartphone usage group has a significantly lower GPA than the low smartphone usage. So our null was mu1 equals mu2. This is the high smartphone usage. This is the low smartphone usage. All right. And whether or not the high smartphone usage had a lower GPA than the low smartphone usage. Well, we got a p-value of 0, which means we rejected the null. So this is what got rejected. We rejected this. All right. Based on the decision above, which of the following is the best response? In other words, what type of error might we have committed? Well, we rejected. So if you reject, the only type of error would be a type 1, because remember, type 2 is a fail to. Well, we didn't fail to, we rejected. So the only one was type 1. Well, that means it gets rid of this and it gets rid of this. But remember, you're not sure that you committed it. You may have committed. So the keyword was may, wasn't was. Because in stats, there's a chance. It's not necessarily saying you did. So our best answer choice is C. All right. So refer to the scenario above and explain the consequences of the type of error that you selected in the context of the situation. So we rejected the null. So we did not believe the truth. All right. Or in other words, we rejected the truth and we believe the lie. Now we didn't do that on purpose. It happened. All right. We had a sample that was weird. So we rejected the truth. We believe the lie. So that means we rejected the null. So the only type of error that we could have been committed was a type 1. That's what we set up here. And notice how we said could have been committed. All right. So what we did is we said, hey, this was the truth. The truth is there is no difference in GPA, but we believe that there is. All right. In this case, we say GPA of the students with high smartphone usage was less because that's what we believe with low smartphone use, when in fact that was wrong. It was false. And we ended up telling students their phone doesn't affect their grades, excuse me, does affect their grades when in fact we end up telling their students their phone does affect their grades. Uh, when it doesn't. The consequences of students that didn't change their phone uses were the consequence is that students could continue to use their phone. The consequences that students could continue to use their phone, but were told not to because they believed it lowered their GPA. All right. So the consequences is that students quit using their phone because they believed it lowered their GPA when in fact there was no difference. All righty. I appreciate you watching and I look forward to seeing you on the next one. Thank you.